Hi everyone, this is Srivathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. S.N.S. Rajalakshmi College of Arts and Science. So in computer networks, we are using two types of reference model. One is a OSI reference model, one is a TCP/IP reference model. Today we are going to discuss about OSI reference model. OSI stand for Open System Interconnection. Is a reference model that describes how information from a software application in one computer moves through a physical medium to the software application in another computer. So it is an abstract description for layer communication and computer network protocol design. It was developed as a part of Open System Interconnection Initiative. It is the most basic form. It divides network architecture into 7 layers, which from top to bottom there are application presentation section, transport, network, data link layer, and physical layer. So OSI consists of 7 layers, and each layer perform a particular network function. So OSI model divides the whole task into 7 smaller and manageable tasks. Each layer is assigned a particular task. So the characteristics of OSI reference model. The OSI model is divided into 2 layers, upper layers and lower layers. So the upper layer of the OSI model mainly deals with application related issues, and they are implemented only in the software. The application layer is closest to the end user. Both the end user and application layer interact with the software application, and upper layer refer to the layer just above another layer. The lower layer of the OSI model deals with the data transport issues. The data link layer and the physical layer are implemented in hardware and software. The physical layer is the lowest layer of the OSI model and is closest to the physical medium. The physical layer is mainly responsible for placing the information on the physical medium. Next, we see the host and media layer. So here we divided into media layer and host layers. So physical layer, data link layer, and network layer, these are the media layers. And transport layer, session layer, presentation layer, application layer, these are the host layers. In physical layer, we represent the bits. In data link layer, we transmit the bits into frames. Then network layer, we are using the packets. In transport layer, we are using segments. Application layer, presentation layer, and section layer, these 3 layers we are using the transferring the data. So these are the host and media layer. Next, we see the protocol for each layer. In physical layer, we are using a medium, uses coaxial cable, fiber cable, wireless or wired. Then in data link layer, we are using the IEEE 802 standards, TR, FDDI, PP physical address. It's a node to node delivery. And then network layer, we are using the protocol, that is internet protocol. Internet protocol is mainly used in network layer. Next, ARP, RARP, ICMP, IGMP, logical address we are using. In transport layer, we are using SCTP, TCP UDP sockets and port address. TCP UDP is the main protocol in transport layer. TCP is a connection oriented protocol. UDP means user datagram protocol, that is a connectionless protocol. So in section layer, presentation layer, we are using in presentation layer to translate the message. Encryption and decryption are using here. In application layer, we are using the protocol telnet FTP, that is a file transfer protocol. SMTP, HTTP, DNS, SNMP, these protocols are used in the application layer. Next, we see the layers one by one. First, we see the physical layer. Physical layer is used to transmit a raw stream over a physical medium. So, it is an electrical or mechanical specification of data. Here, transmission medium, we are using guided medium or unguided medium. So, here we represent the bits. It's a sequence of bits, zeros and ones. We are transferring the data from one place to another place. Here, the data rate, the number of bits sent each seconds. Then a synchronization of bits, the sender and receiver must synchronize at the bit level. So these are the physical layer, or here we are using the topologies. So physical or logical arrangement, we are using mesh topology, star topology, ring topology, tree, bus, hybrid. These topologies are we are using here. Here the transmission mode are simplex, off, and full duplex transmission medium we are using here. Next we see the data link layer. It is a node to node delivery, that is a host to host. It divides the stream of bits received from the physical layer and transferring into the frames. So adds a header to the frame to define the physical address of the source and destination of the frame. Here we are using the error control, flow control, access control. Flow control means to prevent overwhelming the receiver. Error control is to detect any retransmit damaged or lost frames, to prevent duplication of frames. Error correction and detection done by data link layer. So access control is a two or more devices are connected to the same link to determine which device has control over the link to shared channel. So next is a network layer. It's a source to destination delivery of packet across multiple networks. Transmission of packet from source to destination. Here we are using the logical addressing, routing device. These are all we are using. So logical addressing and a header to the packet coming from the upper layer includes the logical address of the sender and receiver. So routing is to create inter-network or a large network that connecting device called routers or gateways. So here we are using the routers devices are we are using. Next, transport layer. It's a end-to-end delivery. Ensure the data is delivered error-free in sequence and with no loss, duplication, or a corruption sequence with corruption. So allow each end-to-end communication between two processes. So with help of TCP and UDP protocol. Then here also we are using the flow control and error control end to end across a single link at receiving transport layer without error damage or loss or duplications. So here we are using the device gateways and firewalls are we using here. Next, we see the section layer. It is a dialog controller. Allows the application to establish, use, and disconnect a connection between them called a section. Provides name recognition, security. So the section establishment, maintenance, and terminations are using here. So the dialog control. It is a communication between two processes to take place either in half duplex or full duplex. Synchronization. It allows a process to add checkpoints into a stream of data. Here also we are using the gateway and firewall devices are using here. Next is a presentation layer. Here we are using the syntax and semantics is very important. So in it is also a translation layer. It determines the format to exchange the data among networked computers. So translation means a receiving machine changed the common format into its receiver dependent format. So encryption decryption is the mainly we are using here. Compression, data compression reduce the number of bits to be transmitted. So gateway firewall devices are using here. The last layer is the application layer. It is a user level service. So the application layer is responsible for providing services to the user. It's concerned with network virtual terminal, file transfer, access and management, mail service, directory service, that is access to distributed database source for global information about various objects and services. So we have seen the 7 layers of OSI reference model. I hope you enjoyed this section. Thank you.